This video is going to teach you how to calculate dilutions of solutions using the formula M1V1 equals M2V2. So in your packet, you have this page about dilutions, and it tells you what they are. Dilutions of stock solutions are a really common way to make solutions of any desired concentration. It's easier to keep one bottle of really concentrated stock solution and then make what you want than to keep a whole bunch of different concentrations. So to dilute a solution means that you're going to add more solvent, usually water, without the addition of any more solute, meaning no more of your ionic compound or covalent compound, whatever it is that's dissolved in the solvent. And then after you've done that, you have to mix it really thoroughly and make sure that it is a homogeneous mixture. The fact that the amount of solute doesn't change, only solvent changes, allows us to make calculations pretty easily. So if we go from a concentrated stock solution to a dilution, if you notice in the picture, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 solute particles in our stock solution. The volume changes up here, but if we count those particles again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we have the same number of solute particles in our dilution. So just to show you how this works, we have the formula for molarity. It's the moles of solute divided by liters of solution. And so I've color-coded things to sort of match here. The molarity, the concentration, is in green. The solute particles are in red, and then the volume of the solution is in blue. This question asks you about this solution here, how many moles of solute, so question mark, moles, are in 0.5 liters of a 3 molar solution. Well, remember that we can rewrite capital M as moles per 1 liter. So really this could be 3.0 moles per 1 liter, and we would use that as our conversion factor here. The way we would need to set it up is so that the liters will cancel out. I'm going to keep it the way it looks right here and put 1 liter underneath, 3.0 moles on top, so these cancel. So what I will need to do is multiply the numbers that are across the top. So let's pull up our calculator. Let's turn on our calculator. And so we want to take 0.5, we want to multiply it by 3.0. We get 1.5. So this comes out to 1.5 moles of our solute, which is NaCl. So what would happen if we wanted to make a dilution? If we just wanted to go ahead and add 0.25 liters of water to that solution, what would the new molarity be? So now it's question mark molarity, and so we're going to come up to the formula and use this. Well, the moles of solute didn't change, right? We still have our 1.5 moles of NaCl. What did change is the volume of solution, the liters of solution. We started with 0.5 liters here. We added 0.25 liters. So if you add those together, we're now up to 0.75 liters of solution total. So to get our new molarity, we need to divide our moles that were the same by our new volume. So let's pull up that calculator again. Let's clear out what we had, and let's take 1.5 divided by 0.75. We get 2. So our new molarity of this new dilution is 2.0 molar NaCl. So that should make sense that the new one is only 2.0 molar. It's less, the molarity is less, the concentration of those particles is less. So in your packet, we have this chart that shows you the formula for calculating dilutions. If we take that molarity before and the volume before and we multiply those together, what you get, that's what we did here. We took that volume, we took that molarity, we multiplied them together, and we got moles. So if we do that for the before situation, then it's going to be equal to the new molarity times the new volume, because that's also going to give you the moles, and the number of moles doesn't change. It's the same number of moles. What's really cool about this formula is that you don't have to convert the volumes into liters. You can use them in milliliters or in liters. They just have to be the same on both sides of the equation. So when we plug in a volume here, it would have to be in liters and liters, or they could both be in milliliters. You just cannot have one of each. So in the beginning, I have you guys fill out this chart to sort of sort the information, because the problem is going to tell you 3 different numbers and you need to keep track of what goes where. So in example number 1, we have 50 milliliters of a solution and they're diluted to a volume of 100 milliliters. So we have 2 volumes and we have to decide which one is the before and which one is the after. Well, since it says to a volume of 100 and that's larger, our final volume is 100 milliliters. The initial volume, the first one, is 50 milliliters. And we don't have to convert them because they're both in milliliters. The concentration, meaning the molarity, of the diluted solution is 2 molar. So the after here is 2 molar. And they want us to find out what was the concentration of the original solution, so we don't know this. So we could put X here if you want, or we could call it M1. I've laid out the chart this way because it mimics the formula up top. This would be M1, this would be V1. This would be M2, this would be V2. And according to the formula, if I multiply the molarities and the volumes, they're equal to the other molarity multiplied by the other volume. So I can multiply these 2 quantities and they would be equal to each other. What that would look like is 50 milliliters times M1 equals 2 molar times 100 milliliters. I can't do anything with the units, none of them cancel or drop out, so this becomes 200 M and ml, and this side is 50 milliliters times M1. To get M1 by itself, we would divide both sides by whatever's being multiplied by it, which is 50 mils. On this side, 50 mils completely drops out. That was the point of dividing. Over here, milliliters drops out, and then we have 200 divided by 50. Well, 200 divided by 50 is going to give you 4, and the units that we could not cancel are M. So what we would say is that M1 is 4 molar. So we could come back over here and say it was 4 molar. So before you call it done, just make sure this makes sense. The concentration before was 4. When we diluted it, it went down to 2, and that should make sense. The second example in your packet is only slightly different. This time you have 53 milliliters of a 1.5 molar solution, but you need 0.8 molar. So when we sort through this information, this would be V1, so 53 milliliters. This would be M1, 1.5 molar. But we need this molarity, so that's M2, 0.80 molar. So we need to know how many milliliters of solvent should we add. Well, this formula only will tell us the total volume of the final solution. So that's what we need to solve for. If we multiply these, they will be equal to each other. For this one, I need a calculator. So pull up the calculator, clear out what we've done before. 1.5 times 53 gives me 79.5. So come back over here and we're going to write that this is 79.5 and no units cancel. I still have all of them. That's going to be equal to 0.80 M times V2. I want V2, so I need to divide what's being multiplied by it. So 0.80 M dividing on both sides completely cancels out on this side. The M's cancel out on this side, and now I need a calculator to divide 79.5 by 0.80. So let's pull that calculator up again. There's our 79.5. Let's divide it by 0.80. We get 99.375. Well, this was 2 sig figs, and this was 2 sig figs, and this was 2 sig figs, so we're going to round that to 99, making it 2 significant figures. So V2 is 99 what? Milliliters. That's what we didn't cancel out. So our V2 is 99 milliliters. But notice that this problem said how many milliliters of solvent should we add? Well, if we add 99 milliliters to 53, we're going to get more than the final volume. So what they're saying is, here's the final volume at 99 milliliters. Here's what you started with at 53. How much did you have to add? So we'll just need to subtract 99 milliliters, and you take out the 53 initial ones, and we get 46 milliliters of solvent is what you should add.